You definitely want to pay attention, right?
Maybe.
Okay, so all this is graded common factors. You guys had this in grade school, okay? The only thing that's different is we're putting exponents in it, okay? So just reviewing, if we're trying to figure out what the factors of 60 are, we divide it down, okay? Everyone tracking? Okay, so 60 divided by 2 is 30, and then 30 divided by 3 is 10, and then 2 times 5 is 10. So these are the factors of 60, okay? 2 times 2 times 3 times 5 is 60. Now, when you're trying to find common factors, you're taking those two numbers and you're getting rid of what's common, which basically is reducing it at the end of the day. Okay? Any questions so far? Okay. When we're using numbers or variables, this is the way you want to write it out. You want to write down 18 and 27, and then you want to stack your factors on top of each other. Okay? So 18 divided, or 2 times 3 is 18, and then 3 times 3 times 3 is 27. So what it has in common when we stack these are these 3's. So the greatest common factor is going to be 3 times 3, which is 9. Any questions? This is easier than doing it this way, in my opinion. You have it stacked up for you, and when you start to get it to exponents, it makes more sense. Yes? No. We're doing this right now. Okay, any questions on this one? We got it? Okay. Okay, next one. Now we have variables. Okay?
No, wait, I don't got it.
Factors. Divide. 60 divided by 2 is 30. 30 divided by 3 is 10. 10 divided by 2 is 5. These are our factors. This is breaking these numbers down. So if we take 2 times 2 times 3 times 5, we get 60. These are the factors of 60. Okay? Then when we're comparing numbers, we write the two numbers next to each other and we factor them out. So 18 divided by 2 is 9, and 9 is 3 times 3, right? So if we take 2 times 3 times 9, we get 18. If we take 3 times 3 times 3, we get 27. Okay? So they share common factors. What they share in this case is 3 and 3 and 3 and 3. So we multiply that, 3 times 3, it's 9. So the common factor between 18 and 27 is 9. That's the greatest common factor, the largest number that can go into both of them.
Question for, you know, we first 60 equals 2 times 2 times 3 times 5.
Yes.
Where did you get that one?
What's 2 times 2? Times 3? Times 5?
No, but I don't get it though. Like,
What's 2 times 2? Take your calculator.
no, where did you get the numbers though?
By dividing it.
So, but why did you actually have to put 2 and 2 together? Why couldn't you put 2 and 3?
Because look, 2 and 2, you usually list them in order.
So it doesn't matter if you list them like
No.
in any way?
I will tell you though, when you get to, no, it really doesn't matter, but normally you go highest to lowest, typically, if you're breaking it out this way. So the 3's and then the 2's. But I knew there was only 1 2, so I listed it first. Yeah, and all we're doing is looking for what's shared amongst the numbers.
So it depends on the numbers too?
Absolutely depends on the numbers. Yep. But everything always has a greatest common factor of 1. No matter what, it's always at least 1. But that's not what you're looking for because that doesn't reduce anything. Make sense? Okay. Okay, back to this one. So we write both these side by side, 3x3 and 6x2. Okay? So 3, we don't usually write 1. Everything is always 1. So it's just 3. And then 6, 2 times 3 is 6. Then we list our x's. We have 3 x's and we have 2 x's. So what's being shared between these two numbers is 3 and our x's. So we take 3 times x and we get 3x2. That is the greatest common factor between these two. That's what we can reduce it by. Any questions? So it helps to write it this way. Get in a habit of doing this. That's normally how you're taught in grade school to do that. But like I said, you want to be writing them side to side, especially with the variables. Make sure the ringer's off, please. Okay, this one, same exact thing. We're 4x2, and then we're 5y3. Okay. Well, 4, it's 2 times 2, and 5 is just 5. It's 5 and 1. So this has x's, this has y's. Nothing is shared but 1 in this case. We can't put either one of these two into each other. The variables are totally different. There's nothing we can reduce on that. So we actually had this problem, 4x2 plus y53 it's reduced. We can't reduce it any further. Make sense?
Oh. Yeah.
Nothing shared here, right? And that's why we break this down. We're trying to look for shared components so we can reduce it. Understand? Can you do me a huge favor? Can you sit towards the front of your desk? Because when I can't see your eyes, I get concerned. Okay, all right, E, just taking numbers, 15 and 28, we're doing the same exact thing. We're going to write them side by side, and then we're going to start dividing, okay? So 5 times 3 is 15, and then 7 times 2 is 14, times 2 is 28. Now, we don't have anything shared here, do we? So these two can't reduce. We can't put anything into this to make this lower. So the only greatest common factor is 1. Normally you say there is no greatest common factor, but you do have to remember that everything at least goes into 1. Make sense?
Mister, why can't you just put 7 times 4?
Because 4 can still be reduced. 2 times 2.
You have to reduce until you can.
Correct. Can we put 7 into anything?
No.
Can we put 5 into anything?
Yeah.
No. What? 2 times 2?
Um,
Okay. So it's either 2, 3, 5, 7. 9 we can reduce. 8 we can reduce. 12 we can reduce. Make sense?
yeah.
Okay, 15x4 and 35x2. Well, they're both divisible by 5, right? So we list them up. 5 times 3 is 15, and 7 times 5 is 35. So we're going to have a greatest common factor of 5, and then we deal with our x's. We have 4 x's, and we have 2 x's. Okay? So it's going to be 5 times x, so the greatest common factor between these two is going to be 5x2. So if you follow it in this format, it's way easier to do. Now, sometimes your problems, they'll get longer depending on the variables. Okay? Any questions on this one? See why we want to stack them up? And you want to put the numbers where they go. Normally, you kind of want to leave space so you can stack them up, but you know, if you're circling them or however you need to do it, it doesn't matter to me. I just find this way is the easiest way to set it up. Okay, next one, 27 and 45. We're going to deal with the numbers first. We're going to write them side by side. Well, 3 times 3 is 27, and then 5 times 3 is 45. Okay? So we have common factors of 3 and 3, and then we have y3, and we have y1. So we're going to have one y. This one has a z, and that's it. Oh, and this one has x's. This one doesn't have x's. So this should represent the number. 5 times 3 is 45. 2 x's, 1 y. 27, 3 times 3, 3 y's, 1 z. Okay? And then stack them on top of each other, then it makes it easier to see what reduces.
Why didn't you put the 5 on the other side?
I could have put it over there, wouldn't have mattered. But normally you want to go in descending order. You want to go higher to lower. Okay, so working on this is 3 times 3, and then y, nothing else is shared. Okay? So 3 times 3 is 9, and y, that is our greatest common factor between these two. Any questions? Okay. All right, next one, 12ab and 12. Well, just looking at this one's pretty easy because AB, there's no variables, so we know this one's all numbers. So if we're 12AB and we're 12, all this should equal this. So 3 times 2, and then 2 is 12. Same thing here. So this is going to be our common factors. They're shared here. So between these two, our greatest common factor is going to be 12. Any questions? Okay, very last one. It doesn't matter how many exponents there are, you're just listing them, okay? We have a 3 here, so we're just 3. And here is 1, but we normally don't show 1. Okay? So we're going to list our m's 8 times. We're going to list our our n's 4 times. Then we're going to list our m's 6 times and our n once. So we know this 6 is going to be shared across the m's, and we know our n's is going to be 1. Okay? So our greatest common factor is going to be m6n between these two. Make sense? Okay. I find that writing it this way, even if it's long, is the best way to do it. You will make less mistakes. Okay? And understand, there's always at least a common factor of 1, but 1 doesn't reduce anything, right? Any number over itself is still the same number, right? So that doesn't reduce anything. It doesn't help us at all. We're looking for things that we can reduce that are like each other. Are we clear? Okay. So, knock this out. We're going to practice some of those problems because Thursday it's going to be this. We'll be through factoring. Look at A3. I'm probably going to have to push that to Monday. Yes.
On E, why is there a space?
Because 5, 5, and 7, normally you want the numbers to be stacked on top of each other. So now if I would have wrote it true, I would have kind of written it like this. 5 and then 3. So 7s, 5s, 3s.
Oh,
You remember how you did problems in grade school and how you lined them up? This really is the same thing at the end of the day. It's making sure that everything is in its box correctly so you get the right decimal places and the right answer when it's all said and done. Okay? So be thankful. This one's easy, right? So we got to get past this one and this one for this week. Okay?
What was it?